Good afternoon, everybody. Everyone gets a data plane. Unfortunately, we don't actually have data planes for you, but we'll tell you all about them today. My name's Dan Williams, and I work on the networking services team at Red Hat with a focus on container networking, Kubernetes, OpenShift, container orchestration, and other related projects like CNI as well. I'm also the co-chair of the Kubernetes Network SIG, lead of the Network Plumbing Working Group, and also a CNI maintainer.
Hi, and I'm Doug Smith. I am in Red Hat's Office of the CTO, and I have a focus on container networking, particularly for NFV use cases, but any of those problems I am just very interested in. I'm a little congested today, so bear with me a bit.
So, quick overview of what we'll be talking about today. First off, we'll talk a little bit about kind of the history of the Network Plumbing Working Group, why it was created and how it kind of came about, what discussions kind of precipitated it. We'll also have an overview of the multi-network specification that came out of that group that we've been working on for the last year and was finally, the version 1 was finally agreed on and released a little bit earlier this year. And then after that, a little bit more explanation about some stuff. I'll hand it over to Doug, where he'll talk about the meta plugin that the group has been working on as a reference implementation of that specification over the last, 8-9 months, something like that. And Doug will go all through that plugin, explain what it does, and give some examples of how the configuration works for it and exactly how it actually hooks up pods and containers to multiple networks. So, what do we actually mean by all of this for multi-networking? For the most part, Kubernetes applications, they don't really care about networking beyond the fact that they have an IP address, that they might be the back end for a service. Everything works great, you're in the cloud, and you can just forget about the network and build your application the way that you want to build it and have it all run perfectly. However, there are some cases, and this is the things that we found out and tried to identify over the last year in the plumbing working group, where that's not always the case. That doesn't always work out for everybody. A lot of these workloads have special requirements on the network, and it may end up being that you need to think a little bit more about the networking, and your pod needs to think a little bit more about the networking as you try to accommodate some of these requirements in Kubernetes. So what do we actually mean by any of these workloads? These are some of the things that we identified. For example, if you have specific performance and bandwidth requirements for your application, oftentimes that can't be accommodated by a lot of the cloud providers. So a lot of companies are looking at on-premises deployments for Kubernetes to kind of provide their own hardware that might have or be able to provide for these special requirements. Alongside that, there are also latency and QoS requirements. Sometimes you don't necessarily want all of the control plane traffic for the entire cluster where the nodes are talking to the masters and the API servers and all that kind of back and forth communication that actually runs and orchestrates your cluster. You don't necessarily want that to impact your data traffic. And in the default case, most clusters are organized so that all of the pod data and control traffic for the cluster go over the same network link. And if you want to make sure that your application has specific requirements on latency, QoS, guaranteed bandwidth, you may not be able to use the same networks that the control traffic goes out over. Also, some businesses have requirements around segregated networks for security or regulatory or whatever means that mean that some traffic has to go over one network, some traffic has to go over another. Oftentimes that means physically separated networks. And one of the last areas that we identified was for legacy network resources where you might have something like a database or some other application outside your cluster that you cannot actually move into the cluster or that you cannot renumber for whatever reason, and so you want your pods to be able to talk directly to that resource. This doesn't mean that you can't do some of these things in a more cloud-native way or have proxies that bridge these kinds of resources back to your cluster, but oftentimes that's a little bit more complicated than a lot of people want to deal with. So Network Plumbing Working Group. What is this working group? Well, Red Hat helped found this working group as a result, or last year at KubeCon Austin. That was really the kickoff and impetus for the group. And it was founded to take a lot of the concerns and questions around how we take these workloads and make them slightly more cloud native, slightly more Kubernetes aware and containerized, how we address some of those needs in Kubernetes. We'd had discussions around this in the SIG network for quite a while before that. And we decided that we should take these discussions and make them more focused and try to address these problems before we bring them back to SIG network with more concrete proposals. So the group's currently focused on addressing multiple networks in an out-of-tree solution. We had a pretty hard goal of not changing the Kubernetes API in any way because that was one of the contentious points. So we decided that we were going to gather a lot of these use cases, come up with a specification that we would then propose eventually to SIG network and to the Kubernetes community once we'd really solidified what we wanted to do and how we were going to address that. Another goal is to provide a reference CNI implementation, which Doug will talk about in just a little bit. We wanted to also, beyond that, as we were trying to move more towards some of the research that we wanted to do around adjusting the Kubernetes API, provide a forum for people implementing these POCs and specifications and refinements to get more feedback from the group first before we actually try to propose that stuff a little bit further upstream. So, and we're continuing to work on these things and expand the use cases that we have even further than the V1 specification and the Multus reference plugin, which Doug will talk about. So we have meetings regularly, every other week. We kind of work opposite SIG network. So if anybody's interested, if you want to help out, we love contributions, we love help. Please join our meetings and help participate. So this is also a kind of another timeline about what happened. We had that impetus for formation of the group over 2017, and then we finally formed the group. We began work on a specification in early 2018, and we kind of refined that specification, got a lot of input from a lot of different members who had these use cases and were able to help us out there. We finally standardized the version 1 specification in early August. And then have been working on the reference implementation since. So what does this specification actually cover? It's kind of a de facto specification. Again, the Network Plumbing Working Group is not an officially sanctioned group necessarily for Kubernetes. It's just kind of an informal group offshoot from SIG network to do these things. But what does the specification cover? It is a short-term solution, and this is, we wanted to make sure that we could do something fairly quickly, get some things done that didn't necessarily require a lot of upstream heavy lifting and coordination. And so we wanted to do something within the next 6 months to 12 months from when we formed the group, as opposed to some of the forward-looking and more research type projects around network services and service function chaining and stuff that are also out there. We did not want to change the Kubernetes API in any way. We also wanted to just have a pretty lightweight standard that could be implemented by multiple different providers, network plugins, other organizations, and it turns out that there are actually a couple, not just the reference implementation that the group's working on, but also a couple other ones, which we think has actually fed back into the spec, helped us refine it a little bit, and really kind of proven the worth of that specification. So a really short overview. There are a couple of different key parts. The first one is an annotation on pods to select these other networks. And you basically select them by name. There is also a slightly more detailed one that allows you to set some other attributes for the pods, which Doug will touch on in a second. And of course, once you have actually attached multiple networks to a given pod, you want to be able to figure out something about that attachment. So that's kind of what IP addresses does it have, perhaps what layer 2 addresses it has, if any, and some other characteristics of that status. So that also we defined, in the specification, we've defined that annotation that then the implementations publish back to the Kubernetes API so that anything that's hooked up to the Kube API can actually figure out what happened on the pod end. And one of the last things is we developed a custom resource definition that describes the networks that you might want to attach to pods, and also requirements for CNI delegating plugins. And what we mean by that is kind of a multiplexing plugin, like the reference implementation that we've developed around Kubernetes calling that multiplexer, which then implements this specification. Not all plugins are like that, but we decided to do some guidelines for the behavior of those plugins so that if you're using this specification and implementation of it, you can be reasonably assured around the behavior no matter which of the implementations you use. So we also got some additional components to help out other implementations and to help out client applications that want to inspect what actually is going on with the network. We have some upcoming stuff too that we're working on that's not quite ready yet, but the first two on that list are actually on GitHub and available for use. And with that, over to Doug.
All right, thank you, Dan. Appreciate it a bunch. What I'd like to talk about here is a reference implementation that we've been working on in collaboration with Intel that we call Multus CNI. You've got it there with a link to GitHub. I would love any sort of exercise that this project can get. Feel free to jump on there, open up issues. We've got a link to a Slack. We'd love to hear how you're using it or if you run into anything. But this particular implementation follows this spec, and we've been using it to kind of give some feedback into how we've developed this specification. And it is fully working. You can pick it up today, you can use it, and you can attach multiple interfaces into your pod using those specifications as Dan mentioned earlier. There's also a fair amount of contribution from other organizations and individuals, so don't be shy. We're happy to get a pull request any day of the week. So let's take a look kind of at what the problem is as we saw it before we started developing Multus as to what it is today. And really, the way I see it, it's kind of twofold. You've got this first part of the problem where you bring up a pod, you execute IPA in the pod, and what do you see? One interface, right? So that's one part. And then secondarily, you've just got one CNI configuration file per node. And in theory, you could have different CNI configurations on different nodes. You could use a node selector, and you could kind of baby where your pods go. And you could get some multiple configurations that way. But in the long run, it's really kind of a maintenance headache to do that, and it's really only one part of the problem, is how do I get a dynamic configuration? So the way that this is designed is that instead of having that one static configuration that's just for a single CNI plugin, that CNI config that's on disk on each node, that really becomes kind of a pointer towards Multus, which is going to distribute that work to other CNI plugins. And we've taken the configurations for your actual workloads, and we've turned those into CRD objects, which I'll kind of give a quick overview of in a minute, too, if you're not familiar with that concept. But generally, it allows us to store these configurations dynamically. So you bring up a pod, and it has this annotation attached to it, which basically says, hey, can I get an extra attachment to a network? And Multus is going to go and look up what that configuration should be for that network interface that's going to attach. It's going to pull down that configuration dynamically, and it's going to say, sure, if you'd like an extra interface and you'd like to back it with a Mac VLAN CNI plugin, sure, go ahead and do that. As Dan kind of touched on, in a lot of ways, Multus looks like a multiplexer. Under the Network Plumbing Working Group nomenclature, you'll often see this referred to as a meta plugin. It's a CNI plugin that's able to call other CNI plugins. So kind of on the left here, we've got the Kubernetes directly calling CNI. So, maybe it would be Flannel that, you'd use for your pod-to-pod network connectivity. But in the case where you do have Multus or another reference implementation that's a meta plugin, it calls that plugin, and then it delegates the work to other plugins as defined by the custom resources that you've created. Some of the key concepts that I think you should be aware of if you go to look at our specification or as you go to use projects that implement it. First of all is something we like to refer to as the default network. Something that we discovered early on as we went to create the specification is that really when you have a pod come up, you expect that it can communicate like your everyday average run-of-the-mill pod. It should have connectivity to other pods. So you'll hear us say default network, and often what we mean is pod-to-pod connectivity. And then we'll refer to the other network attachments, the other interfaces that you have available in the pod. Sometimes we'll refer to those as sidecar networks. Granted, that's a little bit of an overloaded term. Or we'll call them secondary networks or network attachments. Next, custom resources. If you're not familiar with custom resource definitions, it's a term that people often throw around a lot, and sometimes it sounds like more of black magic than it really is. It's really just a way to tell the Kubernetes API to store some data for us. So we have a net definition that says, here's kind of the format of how our data is going to look. And then it gives an application, in our case, Multus CNI, a way to query for that data that you've stored. So in our particular case, what we're using it to store is CNI configuration. So generally, you would take like a typical CNI configuration that you have, and you'd store it as a custom resource. So looking at our standardized CRD, there's kind of two parts that you're really going to be concerned with when you go to actually use this on a day-to-day basis. The first part of it is you're going to have a annotation. So you've got your pod spec, and you've got here in the metadata this annotation section. And in essence, what you're looking to do here is to say this particular pod is going to be attached to these additional networks. You're always going to get the connectivity to your default network, and then you're going to say these are the other networks that I'd like to attach to. Kind of side note, there's two formats to do this. In this particular example is a JSON format. We also have a comma delimited format that's more of a user-friendly way to just type it in so that you don't get carpal tunnel from typing in a bunch of JSON. And those particular names that you see there map down below to our CRD objects or custom resources. And the name there maps directly to the name in the annotation. And then what you're going to do is you're going to pack your CNI configuration into that custom resource. So let's take a look at kind of a step-by-step configuration overview. And let's look at what it would look like when you're right at the command line creating this stuff. First, what you're going to do is you're going to define a network attachment definition. So you can see the kind of this custom resource we're creating is network attachment definition. That's the standardized terminology that we're using as defined by the spec. And you're going to see that it has this name that we can reference in other places. Lastly, we've got the config there. And this is just your run-of-the-mill CNI configuration. So if you've ever created one before, it's the same thing. So we've just kind of got a fancy house for it to live in. Otherwise, it's just completely a CNI configuration. Next, what we're going to do is we're going to launch a pod. And we want to tell that pod that we'd like to use this additional interface that we've defined by the custom resource we just created. So all that we have to do is just create an annotation that references that, that one that we just created. Now, you do not have to have this annotation at all. So if you create other pods that don't need this kind of treatment, they're just going to get the default network. So it's not like all of a sudden all of your pod specs have to change, just the ones that you care about for this particular case. And what happens after you create that pod? Well, you're going to get attachments to multiple networks, and that you're going to see that from user side as executing into the pod, execute IPA, and there you go. You're going to have ETH0. ETH0 is always going to be your attachment to the default network, and then you're going to have incrementally numbered additional network interfaces such as net 0, net 1, net 2, so on and so forth, as you've attached more and more interfaces to your pod. So Dan, what are we looking at for the next iteration of the Network Plumbing Working Group?
That's a great question, Doug. Let's take a look. We want to do a little bit more research in terms of services. Right now, the specification, because of the requirement that we imposed on ourselves not to change the Kube API right away, we can't yet provide services on these additional sidecar networks. They're basically outside of the Kube API. Kubernetes doesn't know anything about these sidecar networks other than the annotations that the implementations like Multus CNI publish back to the pod as annotations. So we're doing some research on that as the group, and some of that's headed by Intel at this point, to try to figure out what would it take to do that. And this was one of the contention points with SIG Network that we had back in 2017 around what changes does it actually take to the Kube API to do multi-network. And it turned out that at that point, various people who looked into it thought that there were a whole bunch of changes needed. And so at that point, the group backed off and was like, well, let's think about this. What do we really need out of it? Now that we've actually got specification implementations for at least a base of multiple networks in the pods, it's time to kind of go back and see what we can do around the service architecture. Because, of course, Kubernetes is really about services, and that's a way, or one of the big things of Kubernetes that enables a lot of the cool stuff that people can do with it. So we're going to go back and try to figure out how we can bring these multiple networks and the characteristics that they provide into a more service-based microservice architecture. We're also going to continue looking at the security for these additional networks. Right now, what we're going to do for access control is fairly limited. We just want to make sure that certain pods that shouldn't be able to access given networks can't. But we're going to keep pushing forward on that and see if we can make that a little bit more granular and flexible. We also have some continuing refinements to the specification. Obviously, specifications are almost never done. And once we approve the V1 spec, there continued to be some things that we wanted to clean up and some additional features that people wanted. One of those that might be interesting is that you don't necessarily have to use a CNI delegating plugin or a meta plugin. Like Multus CNI to do this, there are some groups that want to use elements of the specification, but not the CNI part, so that at least there's a standard way to kind of define some of these additional resources and to publish the status and stuff back to Kubernetes, but not actually have that kind of specific CNI behavior that we've been describing today. We also are putting together conformance testing, and we're going to work on a conformance test framework to at least minimally verify that implementations meet the specification and work correctly as the spec defines. And finally, the Resource Management Working Group for Kubernetes, that's another SIG. There's some overlap with the stuff they work on because when you're talking about high-performance networking, some of these use cases involve special hardware on the machine, and that special hardware is resource-constrained as well, so we don't want to oversubscribe that node and put 50 pods on it when it only has the resources to support 10. So we're looking at how we can work with them to deal with resource management and scheduling inside the Kubernetes cluster.
And for all the stuff that we have coming up. We also would love to invite you to come and help out with the group. I would say if you don't follow this SIG Network mailing list and you're at this talk, that's probably a good thing to follow, but you'll also find a recent thread that we have going where we moved our particular meeting time. So it's Thursday mornings, East Coast time. It's the same Zoom channel as we use for SIG Network, and we'd love to have anyone join up. In short, we just met up. We had a face-to-face meeting yesterday, and we've kind of determined like a series of goals that we'd like to have in the next 6 months to a year. But we're going to start to put together some documentation on that. So if you have concerns, you have ideas, we want to hear them. And I would consider the group to be quite a meritocracy. And if you're able to get in there, do the work, your opinion is going to have a heavy weight on the group itself. So we'd love to have you there. We'd love to have the help. And we really enjoy this stuff, so we'd be really happy to have you and to share that with you.
Also, one last plug for SIG Network itself. A lot of us, there's a lot of cross-pollination between SIG Network and Network Deployment Working Group. A lot of us participate in both groups. And SIG Network also needs contributors. And so if you have an interest in networking, we'd also love to see you in SIG Network as well. So, thanks, everybody. Time for questions, if anybody wants to ask some questions.
Sure.
I have two questions. The first question is, I've seen something of this sort being done by CNI Genie.
Yes.
Are these two communities converging from point?
Yeah.
The second question is, how would your design and the assumptions you have made with the Multus networking would work with introducing, when we introduce Envoy and service mesh?
So the question is regarding other implementations that have similar goals, such as CNI Genie. And this is definitely one of the things that I believe was an impetus of the formation of the group, and certainly something that I was interested in with forming the group is how can we keep this functionality from being balkanized into a whole bunch of different plugins and implementations? And aside from the fact that it's duplicated effort amongst different open source communities, it's actually rather rude to the users of this technology is that you use one, you use it in a particular way, and then you go to use another one and you get a total whiplash from it, right? Because all of a sudden you have to like change your tooling for how you're going to handle this stuff. I can't speak to where CNI Genie is. We have had Peter Zhao from Knitter, which also provides similar functionality. He has participated in the group and has made some progress on implementing the specification there.
Yeah, I mean, speaking from the group perspective, we like multiple implementations because they help prove out the specification and they help us figure out where we made assumptions that aren't actually valid. So we'd love to work with any plugin that attempts to implement the specification. And that's kind of also where the conformance testing comes in, so that we can offer that to people who want to implement the spec and make sure that they actually do. And to be fair, Multus CNI does not perfectly implement the specification currently. We're working on that, but yeah. Yep. Yeah, service mesh. Do you mean service mesh in terms of like Istio, or do you mean service mesh in terms of network service mesh? Okay. Yeah, the question was, how does it work when you have like Istio as a sidecar container in the pod and you have multiple interfaces, and how does the traffic get routed? At this point, that would depend on how those sidecar containers set up the rules. If they have like a default route and they switch the default route to funnel all the traffic through it, through the sidecar, then that could conflict with the multiple networking. But it really depends inside the pod how the routing is set up by the other CNI plugins and what that service mesh might do with the routing table inside the pod to capture that traffic and send it out. But the intent is that only the cluster-wide default network has the services at this point, and so all the service traffic ideally should be going out over that cluster-wide default network interface that every pod gets regardless. Because if you don't do that, then we run into questions of how do you know that two pods that are trying to access a service are actually on the same, actually have a connection and have IP connectivity between each other? And I mean, that's kind of what we're looking at trying to figure out for the next 6 months for the group. Anybody else? You call it, Doug.
Sorry, 3 rows back right there. Sorry, your hand has been up for a while.
Could you speak at all to, like, should I use this to migrate my default network provider in some way?
It's very interesting that you bring that up because we have been looking at that particular use case. A guy on my team at Red Hat has done a couple POCs. Along that, you'll actually find a recent pull request, I believe that we just merged, that says, here's how you can define your default network as a custom resource in order to be able to have some dynamic control over the migration of the default network. So yeah, definitely search through some of the most recently merged pull requests, and you can give that a try.
I think there's a few gaps there still to go, but people are looking at figuring out how to do that.
Yeah, definitely work in progress.
Yeah, and I think that's like at the technical level. There are some other concerns or questions around like, what does that do for your connectivity at a certain point in time? Is there outage? How does that work with service model if you're doing rolling upgrades or something like that? But it's definitely an area of interest that people are looking into.
Cool. Front row here.
Yeah. So the example you gave was MAC VLAN and Bangalore. Let's say you have a couple of interfaces, both MAC VLAN, different subnets, different VLAN. Is the spec the way to define is taking care of that use case as well?
Question was, what if you have multiple network attachments using the same plugin, for example, MAC VLAN, right? Yeah. But different subnets. Yep, yeah, the spec attempts to deal with that. And you just end up with multiple MAC VLAN interfaces in the pod. Each one would have its own subnet. Each one would have its own MAC address. And that information would get published back to the Kube API as separate annotations on the pod for each network. So yeah. And one other quick point about that is that we also spent some time on multiple attachments to the same network. So if you do, for whatever reason, need that capability, we identified, I think, 1 or 2 use cases, pretty limited, but we felt that was important to cover for the spec. That can also work. So, yes?
Same note, there are lots of CNIs that disable use the same CNI plugin provide equal use cases. Calico disable.
I am not exactly familiar with having multiple calicos, but I do believe that we have some, at least in our last iteration of documentation, we actually had some examples in the Multus CNI docs about attaching flannel multiple times, right? And so there was kind of some additional work that had to be done to like separate it out and say like, okay, hey, I'm gonna need to like instantiate multiple daemon sets of flannel, for example. So yeah, it's definitely CNI plugin by CNI plugin. So I guess also kind of worth noting is that Multus will support any CNI plugin that implements the CNI spec as it is today. But that's really as far as it can go because it's sort of out of its hand. It's like a boss that tells you to do a job and then walks away and you do whatever you do, right? Yeah.
So for the heterogeneous config where some nodes have multiple interfaces, so you can have them multi CNI and others have single.
So the question is, some nodes in the cluster have certain capabilities, certain interfaces, and other ones might not. Yep. Yeah. Currently, there's a lot of work going on with the the resource management working group. And so that group is looking at scheduling and making sure that pods don't land on nodes that don't have the hardware. The specification that we have here does not necessarily address that yet, but we're working in close concert with that group to figure out how we can address that, to make sure that, if you use an SRIOV plugin to put an interface into the container, that you have enough of those on the machine that you can do that. And the same goes for even Mac VLAN, because some cards have a certain limit for the number of MAC addresses that they can deal with. So that's not perfect yet, and it's not really addressed yet, but in the future it will be, if I understood the question correctly.
Yeah, and to me, in part, that falls under kind of ongoing discussion about resource classes and classification there. So certainly something to follow along with the group, or come in and help brainstorm along those lines too.
I have one similar to the previous one, but the idea is this second interface that will be managed with Delta will need to be managed and somehow by another software. So can we extend the spec to provide kind of specification for this software in order to be common across all the data network that will be attached to this interface?
Let me see if I've got that right. So the question is, if you have a requirement that the additional network interfaces are managed by an external piece of software, does the specification cover that, which currently it does not? Certainly, we would definitely like to hear your use cases and opinions there to see if this is something that we could cover under the spec, for sure.
I mean, the spec doesn't specifically address that, and I don't think the implementations do either, because once the interface is added to the pod, something has to do that addition, and something could then also manage that interface later. And that's really up to the CNI plugin that is developed to provide that network functionality. So there's a couple of different kinds of plugins, like some of the really simple ones, like the reference plugin set for CNI, and there's others that we sort of call thick plugins that are more heavyweight. They have a process that might run continuously on the machine to manage the connectivity between all the different nodes and pods on the node. For example, Calico, I think, would be more of an example, or OpenShift SDN, of a heavyweight plugin that needs to manage these things over time. So I think it's definitely possible to have that. It's just that the spec doesn't exactly address it, because most of that's left up to the plugins themselves. Any more questions? Yeah, way over there. Question was, what are the capabilities of the current admission controller?
Okay, great question. That's awesome. Yeah, so we have had, I guess this has been a feature that has been implemented in the last couple months. So I believe that it also the last iteration of it is also provides the capability to mutate the annotations as well. So it's going to do some validation of the custom resources as you create them, which we kind of believed would improve the user experience, because it can be difficult to debug if you put something in there wrong. We've also added some improved logging recently, but yeah, the last iteration provides a mutation. And something to look for is we actually recently created a Network Plumbing Working Group GitHub organization, and we're actually going to take the work that's been done on the admission controller for Multus, and we're going to publish it as part of the Network Plumbing Working Group GitHub org, so that we can so that anyone who implements the specification actually could use the same admission controller, because we believe that that's probably agnostic to your actual implementation.
Yeah, we plan to put kind of plug-in neutral or vendor neutral resources on the GitHub org for the Network Plumbing Working Group. We currently have a generated CRD client code there, so you can actually use the CRD from some of the normal Kube APIs for list, watch, get, that kind of thing, and not have to do raw HTTP requests yourself. So that's pretty cool. And the specification is also there in a couple of different formats. And like you said, the emission controller will be there fairly soon. So we intend for that to be a place where not just plugins that implement the spec, but also other clients that want to read the pod annotations to figure out what the status of these different attachments is, or even add or remove or mutate the list of networks. I think we're pretty much out of time, if I'm correct. But if you find us somewhere else out there, feel free to stop us and talk. So, thanks everybody.
Thank you.